Good day, everyone. My name is Jima, and there's someone known as Gas, and today we are here to elaborate you on measures of variation. So measures of variation. So under measures of variation, there are four key words or key terms you would have to know. We have range, we have mean deviation, we have standard deviation, and we have variance. We have variants. So I'll be going through this with you. We'll take them one after the other, one after the other. So we are beginning with range. Range, it is the simplest measure of dispersion, and it is the difference between the highest and the lowest values in the data set. If you remember the first video we did on business statistics, I taught you what the range is. So the range, you subtract the lowest value from the highest value, then you get your what? Your range. We move on to mean deviation of ungrouped data. Mean deviation of ungrouped data. It is the arithmetic mean of the absolute values of deviations. It is the arithmetic mean of the absolute values of deviations from the arithmetic mean. And in the previous video, we taught arithmetic mean. So as I said, business statistics is step by step, is one after the other. If you miss a process, there's no way you are going to get to the other. If you miss a process, there's no way you are going to get the other. So now, mean deviation. So this is the formula for mean deviation when it comes to the ungrouped data. Now you know what range is. So this is the formula for mean deviation. So mean deviation, the MD, because sigma, then the absolute value, which is this stroke, comes your x minus your x bar divided by your n. So the x is the value of each observation. The x bar is the arithmetic mean of the values, and you know how to calculate your arithmetic mean. And the n is the number of observations, and this stroke is the absolute value. So now there's an example here. It says the number of patients seen in the emergency room at St. Luke's Memorial Hospital for a sample of 5 days last year weeks was 103, 97, 101, 106, and 103. Determine the mean deviation and interpret. Determine the mean deviation and interpret. Determine the mean deviation and interpret. So as soon as you see this, now let's interpret and let's solve the question I just read to you. So with the days, it gave you 1, 2, 3, 4, 5. It says the number of patients seen in the emergency room at St. Luke's Memorial Hospital for a sample of 5 days. So a sample of 5 days. So these are the days. It says the number of patients seen in the emergency room at St. Luke's Memorial Hospital for a sample of 5 days last year weeks is 103, 97, 101, 106, and 103. So number of cases. Which will be your x. Which will be your x. X 103, 97, 101, 106, 103. So now we will be finding, let's take to the formula. The formula is sigma sigma absolute value x minus x bar over n. This is the formula. This is the formula. So now we have our x values here. We have our x values here. We have our x values here. So now what we are doing will be the x minus your x bar. Now, how then do we find our x bar, which is our arithmetic mean? So now with the arithmetic mean, as taught in the previous video, what you are going to do is that you are going to add all these values divided by the what? The number of observation. So we have 03 plus 97 plus 101 plus 106 plus 103 510. So 510, the number of observation is what? Is 5. So you divide it by 5. So our arithmetic mean is 102. Our arithmetic mean is 102. Is 102. And our arithmetic mean is 102. And the total of this was 110. Was 110. So now let's do our calculation here. You are going to subtract your, you are going to take your arithmetic mean from your x, and we've calculated our arithmetic mean given to be 102. So now let's do our, we have our arithmetic mean here, and now we coming to solve for this, the absolute values must come. And when the absolute values come, when you do your calculation and you get a negative number, the negative will then change to positive as a result of the what? Absolute values here. The absolute values here. Good. So let's do our calculation. When you subtract 102 from 103, you are getting 1. You are getting 1. When you subtract 102 from 97, you are getting negative 5. So as a result of the absolute value, it will become positive 5. When you subtract 102 from 101, you are getting negative 1, but it will change to positive 1. When you subtract 102 from 106, it will become 4. And when you subtract 102 from 103, it becomes 1. It becomes 1. So now we have this here. So now we have this. So let's get the tally, the total. So 1 plus 5 plus 1 plus 4 plus 1. You are getting 12. You are getting 12. You are getting 12. So now let's fix it into our formula. So we have this to be what? 12 divided by our n, divided by 5. Our n here is the number of observation, which is 5. So you divide the 12 by 5. And when you divide 12 by 5, you are getting 2.4. You are getting 2.4. You are getting 2.4. So this is how you calculate for our mean deviation of an ungrouped data. Of an ungrouped data. So we move on to mean deviation of grouped data. We move on to mean deviation of grouped data. So mean deviation of group data comes with steps. So now step 1 is determine the mean for the frequency. Step 2, determine the absolute deviation of the midpoint of each class from the mean. Step 3, multiply the absolute deviation by f. Then step 4, compute the arithmetic mean of the absolute deviation. So now we have an example here. It says compute the mean deviation for the frequency distribution for the table below. It shows the annual income of 50 employees. Shows the annual income of 50 employees. So we will draw our table here. So now this is our table. So per the question, the class limit was given. The class limits were given. So we have 120 maps on to 139, then 140 maps on to 159, then 160 maps on to 179, 180 maps on to 199, 200 maps on to 219, 240 maps on to 220 maps on to 239, 240 maps on to 259. Then 260 maps on to 279. 79. Okay. So now the F was given as what the frequency. So we have 1. Okay. So our frequency is 1, 4, 10, 14, 12, 6, 2, and 1. So now we would have to find our class midpoint. Then we find our fx. Then we find our absolute deviation. Then we find our f sigma f. Yeah, the sigma f has already been given as well. So now let's find our class midpoint. How then do we find our class midpoint? We add the lower class limit to the upper class limit, then we divide by 2. So now we have our class midpoint, our x here. So now how then do we find our fx. How then do we find our fx? We multiply our f by the x here. So when you multiply 1 by 129.5, you get 129.5. When you multiply 4 by 219.5, you are getting 878. We multiply 10 by 169.5. You are getting 1695. We multiply 14 by 189.5. You are getting 2653. We multiply 12 by 209.5. You are getting 2514. We multiply 6 by 229.5. You are getting 1377. We multiply 2 by 249.5. You are getting 499. And we multiply 1 by 269.5. You are getting 269.5. So now we have our fx. Now let's find the mean. Let's find the absolute deviation. Let's find our absolute deviation. So now we have our x. We now have our x. But now we have to first find our absolute we have to find our arithmetic mean. The arithmetic mean, we tally all this, which is the sigma f. So 1 plus 4 plus 10 plus 14 plus 12 plus 6 plus 2 and plus 1. You are getting 50. Then 50, you divide by the number of observation. We have 1, 2, 3, 4, 5, 6, 7, 8. So you divide the 50 by 8, and you are getting 6.25. 6.25. 6.25. 6.25. So now 6.25 is now our arithmetic mean. So we would have to subtract the 6.25 from our class midpoint, which is the x. And as a result of the absolute value here, when you get a negative number, it turns to positive. So 6.25. So now let's do our calculation here. So 129.5 minus 6.25. 219.5 minus 6.25. 169.5 minus 6.25. 189.5 minus 6.25. So this is our absolute deviation. We have our absolute, and we have our absolute deviation values here. So now what you are going to do is that you would have to multiply this absolute deviation by your f in order to get this. So this is what we are talking about. So we take our calculator, then we multiply f, which is 1, by 123.25. We are getting the same value. And multiply 4 by 213.25. You are getting 853. And multiply 10 by 163.25. You are getting 1632.5. When you multiply 14 by 183.25, you are getting 2565.5. Multiply 12 by 203.25, you are getting 2439. Multiply 6 by 223.25, you are getting 1339.5. And multiply 2 by 243.25, you are getting 486.5. You multiply 1 by 263.25, you are getting 263.25. So now, after getting this, what you do is that you add all this. You add all this to get your sigma f as absolute deviation. 123.25 plus 853 plus 1632.5 plus 2565.5 plus 2439 plus 1339.5 plus 486.5 plus 263.25. And do that, you are getting 9,702. 9,702. So now let's state our formula. The formula for mean deviation of grouped mean deviation from group data is MD equals sigma f, absolute deviation, divided by sigma f. So now this sigma f absolute deviation is what we did here. So you tally all this, and when we did that, we had 9,702.5 divided by our f, and when we tally all this, we are getting 50. We are getting 50. So when we divide 9,702.5 by 50, we are getting 194.05 as our mean deviation. So this is how we calculate mean deviation of group data. Mean deviation of grouped data. We move on to variance and standard deviation. When we talk of variance, it is the arithmetic mean of the squared deviations from the mean. It is the arithmetic mean of the squared deviations from the mean. Standard deviation, it is the positive square root of the variance. It is the positive square root of the variance. So we would have to move on to population variance for ungrouped data, and also population standard deviation for ungrouped data. Then we move on to that of grouped and the others. So with population variance for ungrouped data, so population variance for ungrouped data, population variance for ungrouped data. So this is the formula. So this is the formula for population variance for ungrouped data. So this is population variance, and the x is representing the value of an observation in the population. The value of an observation in the population. So with the x, you know how to get your x, and you know where to place your x. With this u is the arithmetic mean of the population, and the n is the total number of observations in the population. And thank God you are used to this, because we solved examples on these arithmetic mean and observations and all that, so you know what this means. So when you're done, then you square it. So this is the interpretation of the formula, and as time goes on, we are going to show you how to use the calculator to find the population variance of both the grouped and ungrouped, and also population standard deviation for ungrouped. Population standard deviation for ungrouped. This is the formula. This is the formula. So it's the same as what we interpreted, but there is an additional touches here. There's an additional touches here. So this is the formula. So as time goes on, we'll solve examples on the population variance and also the population standard deviation using the calculator specifically. My name is Jima Ade Samuel, known as Gas. Thank you.